Hello, we are Laia and Marta, and we will present the experiment 5b, which is the synthesis of benzocaine.
Benzocaine is a type of anesthetic drug which is for pain reliever. It's a central nervous system depressant. That refers to physiological depression of the central nervous system that can result in decreased rate of breathing, decreased heart rate, and loss of consciousness, eventually leading to coma or death. Anesthetic is a drug that causes anesthesia. That means that it's a reversible loss of sensation. Benzocaine is a local anesthetic which causes reversible local anesthesia. The general structure of a local anesthetic includes a substitute aromatic ring bonded to an ester group, which in turn is bonded to a central carbon chain, the end of which contains either a secondary or tertiary amine group. The chemical properties of this drug is that it has a log of P 1.86, which means that it has a lipophilic molecule. Also, it has a pKa 2.51, which means that in a pKa under this, we will find benzocaine in the protonate form. And in a pKa higher than this, we will find the unprotonated form, that is more soluble in water. The melting point is between 88 and 90 degrees. It has a molecular weight of 165.19 grams per mole. Pain is caused by the stimulation of free nerve endings. When the nerve endings are stimulated, sodium enters the neuron, causing the polarization of the nerve and subsequent initiation of an action potential. The action potential is propagated down the nerve toward the central nervous system, which interprets this as pain. Benzocaine acts to inhibit the voltage-dependent sodium channels on the neuron membrane, stopping the propagation of the action potential. Benzocaine exerts its local anesthetic effect by blocking voltage-gated sodium channels in peripheral neurons. Benzocaine diffuses across the neuronal plasma membrane in its uncharged base form. Once inside the cytoplasm, it is protonate, and this protonate form enters and blocks the pore of the voltage-gated sodium channel from the cytoplasmic side. For this to happen, the sodium channel must first become active so that gating mechanism is in the open state. Therefore, benzocaine preferentially inhibits neurons that are actively firing. Is used in topical anesthesia on the skin and mucous membranes in the form of aerosols or as creams for reduction of pain caused by itching, cuts, and beats. It begins to work 15 to 30 seconds after application and lasts to 12 to 15 minutes. It is also used under the name anesthetizing thermoplast and others. The route of administration are topical and oral. Benzocaine is a derivative of para-aminobenzoic acid and can be synthesized by the Fischer esterification reaction. It can be prepared from p-toluidine by a 4-step synthesis. The problem of a synthesis of this type is that the overall yield of the final product is usually quite low. The 4-step synthesis of the product are acetylation, oxidation, hydrolysis, and Fischer esterification.
We are going to explain the first step, which is the acetylation. Acetylation is carried out using acetic anhydride in a nucleophilic addition reaction to add an acetyl group on the amine group. This, in turn, produces the acetanilide group. Nucleophilic nitrogen attacks the first electrophilic carbonyl on acetic anhydride. The C double bond O bond is broken. The same C double bond O bond reforms, and the next CO bond breaks, expelling the acetoxy group. The loss of proton from the product to the acetoxy group produces p-methyl acetanilide and acetic group.
The main objective of this experiment is the preparation of benzocaine. Also, we have to calculate the yield of both isolate products, determine the melting point of both isolate products, check the purity of all compounds, by thin layer chromatography using the appropriate eluent, and also we have to analyze it by air spectroscopy.
As Laia has said, this reaction occurs in 4 steps. The first is the preparation of the N,P-toluol acetamide. The second is the preparation of P-acetamidobenzoic acid. The third is the preparation of P-aminobenzoic acid. And the last is the preparation of ethyl P-aminobenzoate, which is the benzocaine. We will focus on the first step. First, we add 8 grams of p-toluidine in a 500 ml beaker and a solution of concentrated hydrochloric acid 8 ml in 200 ml of water is added. The mixture is heated at 50 degrees in a water bath and stirred until complete dissolution of the amine. In this point, a yellow solution is expected. The solution is cooled down with the aid of an ice water bath. To this mixture, 100 ml of a solution of sodium acetate trihydride and 9 ml of acetic anhydride are sequentially added with continuous stirring. The resultant crystals are filtered under vacuum, washed with cold water, and analyzed by TLC, which is thin layer chromatography, using ethyl ether and hexans as eluent, and the first is 7 times more concentrated than the second.